Radiocarbon dating. We have already learned how scientists use the process of radiometric dating to calculate the age of rocks. In this presentation, we will learn about one specific kind of radiometric dating called radiocarbon dating, which is used to calculate the age of things that used to be alive, like fossils. Remember that this chart represents all the elements that have been discovered so far. Each element is made up of protons and neutrons. The top number tells how many protons are in an atom of the element. Different isotopes of the same element have the same number of protons, but different numbers of neutrons. Two different carbon isotopes, carbon-12 and carbon-14, are involved in the radiocarbon dating process. Carbon-14 is involved in the process because its amount decreases. Carbon-12 serves as the standard because its amount does not change. Take a look at this nitrogen-14 atom. It has 7 protons and 7 neutrons. In our atmosphere, when a neutron produced by a cosmic ray reaction collides with a nitrogen atom, it displaces a proton. Because the atom now has 6 protons and 8 neutrons, it is no longer a nitrogen-14 atom, it is now an atom of carbon-14. The lone displaced proton is an atom of hydrogen. This process explains why carbon-14 exists in our atmosphere. Just like carbon-12, the carbon-14 combines with oxygen to form carbon dioxide, which is absorbed by plants during photosynthesis. Animals and people who eat the plants take in carbon-14. Carbon-14 is only a tiny fraction of the carbon found in the atmosphere. For every trillion atoms of carbon-12, there is only 1 atom of carbon-14. This ratio of carbon-12 to carbon-14 in the air and all living things is nearly constant. But after they die, living things no longer take in new carbon. After the death of trees, animals, or people, wood and bones lose carbon-14 as it changes by beta decay back to nitrogen-14. Scientists can measure the amount of carbon-14 with a mass spectrometer. By comparing the amount of carbon-12, which continues to remain the same, with the amount of carbon-14, which is decreasing, and then comparing that ratio with the expected decrease in carbon-14 with time, scientists can calculate how long ago the living thing died. Remember that to begin with, there is only 1 carbon-14 atom for every trillion carbon-12 atoms. Detecting carbon-14 atoms after several half-lives is a little like trying to find 1 red grain of sand in an entire football stadium filled with sand. Carbon-14 has a relatively short half-life, only 5,730 years. Because it is so difficult to detect carbon-14 after 10 half-lives, radiocarbon dating can only be used to date previously living things that are less than about 50,000 years old. Like other forms of radiometric dating, the accuracy of radiocarbon dating is dependent on the accuracy of certain assumptions. Carbon dating assumes that the decay rate has always been constant. Even though we know that the amount of carbon-14 in the atmosphere has changed over time, we believe we can correct for that. Interestingly, even though radiometric dating methods suggest that rock layers of the geologic column are many millions of years old, trace amounts of carbon-14 have been found in fossils from those very same rock layers. If the fossils are really millions of years old, no carbon-14 should be left. In other words, the millions of years calculated for the rock layers conflict with the thousands of years implied by the presence of carbon-14 found in the fossils. This just means that there are still things about radiometric dating that scientists don't understand yet. Scientists who believe the Bible to be a reliable account of Earth's origins are looking for alternate explanations for radiometric dates. They predict that there are discoveries yet to be made that will explain the data in ways that are consistent with Scripture.